Hello students, serious question. A sphere of mass 20 kg is suspended by a metal wire of unstretched length 4 meter and diameter 1 millimeter. Okay, so when in equilibrium there's a clear gap of 2 millimeter between the sphere and the floor. So this is your pendulum. Okay, the length of the wire and mass of the pendulum, everything is given, and they're saying that there's a gap of 2 millimeter when the sphere is just hanging in its natural position. Correct. But now when the sphere is gently pushed aside so that the wire makes an angle theta with the vertical and released, you take the sphere on one side and release it. So now it will start oscillating, it will perform oscillations. Correct. So what will happen due to the oscillations as the sphere again comes down at the bottommost point, it will have some velocity. Due to this velocity, you could say that in the frame of the sphere, in the reference frame of the sphere, centrifugal force will be acting downwards. Because of the centrifugal force and gravity, the tension in the wire will increase and therefore its length shall also increase. Okay, length will increase due to centrifugal force, we could say. All right, so that's the only concept we have to apply over here, nothing new. So let's say that the system was released from angle theta. Okay, the sphere was at this position. So what is the height of the sphere in this position? This height will be L cos theta and total is L. So this will be what? L times 1 minus cos theta. Okay, so what is the velocity at this point? V. By energy conservation we can find V will be under root of 2gh. Correct. So that will be under root of 2gl 1 minus cos theta. Now see, when not oscillating, when not oscillating, tension is equal to mg at the bottommost point. Okay, and when oscillating, tension is equal to mg plus mv square by radius is L. So due to this extra tension created, the length of the wire will increase and this gap will be gone. Okay, the maximum tension we could have should be such that the wire should elongate by only 2 mm and not more than that. Okay, maximum elongation should be 2 millimeter. Okay, so this is the change in tension mv square by L and it is creating this elongation. So just apply Hooke's law for this thing. Okay, so delta T divided by area equal to y delta L by L. So delta T will be mv square by L. Okay, times area will be equal to y and delta L is what? 2 millimeter. We will put the value later on. Okay, divided by L. So this L will get cancelled out. So we'll get V square equal to YA delta L by M. Now, what is the value of V square? V square will be 2GL 1 minus cos theta. So 2GL 1 minus cos theta will be YA delta L by M. So from here you will get cos theta will be equal to 1 minus YA delta L by 2 mgl. So now just put the values given in the question and we can find theta. So here I have put the values and you will get the answer to be 1 minus 0.2, this should be 0.8.